Yeah, good afternoon, all. Welcome to the satellite applications in weather and climate. This is last day class. So, Dr. Vijay,
Yeah, yes, sir. Am I audible?
is it my voice is audible?
Yeah. Your voice is clear.
Yeah. Hello.
Yeah, hello, sir. Am I audible?
Yeah, is it audible?
Okay.
Yeah, Dr. Vijay, please introduce yourself and start the today's session.
Okay, sir. Okay. So, up to what time I can take, sir?
Uh, as your wish, 4:30 around 4:30 or 5 o'clock. Up to 4:30 will be the
Okay.
class, and after hour will be the discussion.
Yeah, sure. So, let me share my screen. Sir, is my screen visible? Hello?
Yeah, sure.
Yeah, okay. So, good afternoon, all. This is Vijay Prakash. Um, I completed my PhD from Indian Institute of Technology, Madras. During my PhD, I worked on satellite oceanography. Particularly, I developed some deep learning models to estimate ocean heat content from satellite-based data. So there we consider study area as our Indian Ocean and Pacific Ocean, Atlantic Ocean, and particularly Arctic Ocean as well. So after completion of my PhD, I joined here in INCOIS, Hyderabad as a postdoctoral scientist. So currently I'm working under ITCO program here. So that is about my brief introduction. So we can start our today's presentation. So I think for last 4 days, you listened lectures related to atmospheric studies, air pollution, and forest fires. So likewise, some different domains how satellite applications can be applied. So such topics you might heard about. So in this lecture, I am going to talk about how satellite-based data can be utilized for various oceanographic studies, particularly with particular focus on weather and climate. So here is the outline of my today's presentation. So first, I will give you some brief introduction about ocean remote sensing, or we can say satellite oceanography. Maybe this introduction may be around 10 to 15 minutes like that. So afterwards, I would like to give you some insights related to essential climate variables. There are many essential climate variables recognized by reputed organizations. So based on the time constraint, I would like to touch upon temperature and chlorophyll. So, how satellite-based data can be utilized for temperature related studies, and how chlorophyll can be, uh, I mean, how such some applications we can deal with chlorophyll. So that is like in this second portion, as I mentioned, I will touch upon how temperature and chlorophyll data can be utilized for various weather and climate related studies. How, what are all the various satellite based sources and even corresponding in situ sources. Like that, I will discuss certain details related to particularly temperature and chlorophyll. And during discussion time, you can even ask any other parameters of your interest, not only temperature and chlorophyll. So, and then mainly in this presentation, I would like to focus more on analysis methods. So means we can gather data from different websites. Either it may be satellite data or EC2 data for validation. So once we have data for a couple of years or couple of months, how we can work on the available data. So for that purpose, there are different ways of analysis methods. So I would like to give you some critical insights on how what are all the various analysis methods that can be used for weather and climate studies, particularly in the context of oceanography. So, what is the importance of each study? What are all the critical points one has to consider when we carry out such analysis? And I would like to touch upon how these analysis what consideration we should have when we target some publications or manuscript writings, what kind of uh, key points we should consider in each kind of analysis. So, and then it follows conclusions. So, hope with this outline, I am expecting by the end of this lecture, uh, you may be a beginner related to satellite oceanography, or you may be already working on satellite oceanography. I feel definitely this lecture will be helpful in terms of uh, covering certain fundamentals related to satellite oceanography, and then various data sources related to temperature and chlorophyll and other essential climate variables, and followed by different analysis approaches. That is somehow uh, critical for whoever already working on satellite oceanography related topics. So, yeah, coming to satellite oceanography. So this is like a brief introductory slide related to ocean remote sensing. As you already hearing last 4 days sessions related to satellite oceanography, or not satellite oceanography, to be precise, remote sensing application. So we all know what is the importance of remote sensing compared to field measurements. So particularly when we talk about oceanography, so since oceans are covering almost two-thirds of the Earth's surface, more than two-thirds of the Earth's surface, so obviously, whatever field instruments or field data we are collecting from different platforms, that is not at all sufficient to study oceans adequately. So because of their vast coverage, and most of the uh, regions are somehow difficult to access also. So obviously, when we talk about oceanography, ocean remote sensing is a very much powerful tool. It has plenty of applications. So obviously, in that way, we can understand the importance of our expertise in terms of satellite oceanography. So, and obviously, when we talk about advantages, we can say obvious spatial coverage, synaptic views, and regular or repetitive temporal coverage, and obviously in terms of cost effective, and moreover uh, observing multiple parameters at a time. So in the we can list many advantages when we talk about remote sensing. And as I just mentioned, unlike land remote sensing, when it comes to oceans, since majority of the areas are not accessible to us, not that easy to go and take observations. Obviously, remote sensing applications are found to be very much required. So, and when we talk about satellite oceanography, what are all the sensors we use? So here I listed different types of sensors. So in the context of oceanography, ocean remote sensing. So when we talk about visible remote sensing. So in ocean remote sensing, we particularly use ocean color radiometers. So these are passive sensors. These whatever data that we are going to collect using these ocean color radiometers are highly useful in order to study water constituents like chlorophyll A, so chlorophyll A concentration and suspended particulate matter. We can even say turbidity, so nutrients. So likewise, different parameters related to water quality. So such parameters related data, we can actually get it from ocean color radiometers. So these ocean color radiometers, as I just mentioned, they actually passive sensors, they collect the water leaving radiance from the ocean surface. So based on that, at sensor collected radiance data at different wavelengths. So based on that radiance observations, we can actually apply some inversion techniques to estimate different water constituents. So our raw measurement will be radiance at different wavelengths. So based on the inversion approaches, we can actually estimate, as I mentioned, chlorophyll A concentration, suspended particulate matter, like the different water constituents we can actually estimate. So there are some standard algorithms. So by using those algorithms, we can actually estimate these constituents. In the coming slides, I will show you one such algorithm for your understanding as well. So, and then coming to thermal infrared region. So there are some sensors, we can say AVHRR. So with such sensors, we were able to get the data related to temperature, particularly sea surface temperature. So when it comes to sea surface temperature, here the measuring principle is actually based on the brightness temperature data recorded by onboard sensor, onboard satellite sensors. So by observing the brightness temperature data, we can actually develop some models so that we can estimate sea surface temperature. So, and then when we talk about microwave radiometers, this is actually microwave data in the passive remote sensing, passive category. So this is actually mainly we are using this passive microwave data for salinity observations, and particularly even some sensors are there, they can measure SST data. And but mostly we use thermal infrared sensors for SST. And coming to active type, we have scatterometers. They give wind speed and direction related data based on the sea surface roughness. So scatterometers actually they are capable of measuring sea surface roughness. That roughness can be related to wind speed and direction. So, and coming to altimeters, we can say these altimeters are like radars. So, based on the two-way travel of radar pulse from the sensors to sea surface and again sea surface to sensor, based on this two-way travel time and the speed of light, so we can actually compute the we can relate that to the whatever the sea surface variations we can observe. So these altimeters are mainly for analyzing sea level anomalies. And then coming to SAR, synthetic aperture radar data, it is like a imagery image formed image kind of data we actually use for oil spills and different oceanic features. And I can give you with some example related to oil spill, some more explanation. So usually synthetic aperture radar that actually measures backscattered signal from the object. Let's say if it is our ocean surface, so from the ocean surface, whatever backscattered signal is coming towards the sensor, that our SAR sensors are actually capturing. So whenever there is a oil spill, that area will be like a very much smooth surface. So obviously there won't be uh, there won't be, technically we can say, there won't be no backscattered signal from that region. So if we see SAR imagery, so if any oil spill is there in those areas, we can see black portions. So like that, there are different applications of SAR data. So this is about different sensors in the category of passive and active, particularly various oceanographic applications by means of measuring various parameters and relating those measurements to different physical parameters. So, and obviously, when we talk about spectral regions, so as I just mentioned, in visible region, we are actually using for ocean color applications. In detail, if we talk about means chlorophyll and water quality related studies. So, and then coming to near infrared, so related to aerosols, land water demarcation, particularly if somebody wanted to study shoreline dynamics or mangrove mapping. So, for such studies, these near infrared bands are highly useful so that we can clearly uh, demarcate the boundary between land and the ocean. So obviously, we all know about how near infrared data is useful for vegetation applications. So, and as I just mentioned, thermal infrared data we can actually use for sea surface temperature related applications and microwave for all weather observations. So, so this is about some briefing related to various sensors and the spectral regions in the context of ocean remote sensing. So, and here I listed some fundamental parameters we actually use in ocean remote sensing. Chlorophyll, total suspended matter, turbidity, sea surface temperature, salinity, sea surface height, significant wave height, currents, winds, and different coastal features. And these are the various uh, widely used satellites or sensors for corresponding parameters, and these are all the various applications. So if you are expecting any further discussion about these fundamentals or these oceanography related parameters or sensors or applications, you are actually welcome. You can ask whatever questions clarify you want to get clarified. So, and particularly I would like to mention here, so apart from ocean ocean dedicated ocean related sensors, in oceanography we are even using some earth observation satellites, particularly we can say Landsat, Sentinel-2. So these multispectral what we can say land remote sensing satellites also we are using particularly to study coastal features. So not only image-based data, we can apply Landsat-based or Sentinel-2 based whatever data in the form of digital numbers. Those digital numbers we can actually use it for aquatic applications also. So particularly there we actually focus on coastal water quality such studies. Okay. So, and some specifications of different sensors. Ocean color monitor. This is our ISRO's sensor, high spatial resolution in the context of oceanography, 360 meters. So with the 2 days repeativity, or we can say 1 to 2 days repeativity, and these are all the key parameters. And MODIS Aqua, INSAT 3D, Sentinel, Landsat. These are all the different satellites and their spatial resolution, temporal resolution, and their fundamental application. So, and then coming to ground truth data. So, when it comes to oceanography applications, we have a lot of satellite data, different sensors. So, for in every application, so whatever application you are working on using satellite data, obviously when you submit a paper or when you submit a report, obviously a committee or reviewers will expect the validation. So whatever data you have, you are going to use as input, that you should validate before you use. And once you obtain some results, if any possibility is there, you have to validate those results also. So in that point of view, when we are interested in working with satellite oceanography applications, we must have some fair idea about the different in situ platforms and different in situ based measurements as well. So that's why here I put this slide. So we have field observations related to more based from moored buoys and drifting buoys, Argo floats, ship-based observations, and coastal stations. So, if you need any further details about these field in situ platforms, how they function, if you want any details, you can always ask me. You can interrupt me also. That is okay. So, I will give you some briefing before I move on to next slide. So if you are interested in analyzing time series variation of any parameter, whether it is temperature or winds or ocean currents or waves, if you are interested, if your study is related to time series observations at single location, then moored buoys data is actually useful for you. And let's say if you are interested in studying uh, ocean currents, how, or we can say, if you are interested in tracing some elements, so there obviously we need ocean currents data along the trajectory. So in such cases, drifting buoys are found to be useful. So whatever sensors we are going to deploy along with these drifting buoys, when that buoy is actually drifting based on the winds and the currents, it will continuously collect data on its course. So such data is useful when you deal with, where if you are studying any applications related to ocean circulation, are tracing any element or pollution contaminants. So in such cases, drifting buoy data is found to be useful. As I just mentioned previously, moored buoys are like fixed. They actually fixed in some single location and they continuously measure data at that location. So that's why they are actually useful for time series observations. So, and coming to Argo floats. So these are actually uh, their main interest is to collect data at subsurface level, means from surface to up to 2000 meters depth. So from surface to 2000 meters, these Argo floats will actually measure temperature and salinity when they design. First, they design up to 2000 meters in a 5 days time, and in and then from 2000 meters to surface, they will, when they ascend, during that ascend time, these Argo floats will actually measure temperature and salinity data. So plenty of data is available in the Indian Ocean as well as in the global oceans. So these Argo floats, not only they are measuring temperature and salinity, currently uh, some Argo floats, they are actually capable of measuring biogeochemical parameters as well. So if you can search like BGC, biogeochemical BGC Argo, definitely you can find such floats information, whatever data they are actually collecting. And obviously, when we talk about ship-based observations, so we many of our Indian institutes and even abroad institutes, so they are actually conducting a lot of cruise to collect different parameters. Actually, these ship-based observations are mainly people actually focus when we wanted to collect this data along a transect. In general case, I am saying. So if our interest is to collect ocean observations along a transect, it may be from particular coast to few kilometers inside the deep ocean, or any other means. It depends. So if we are interested in collecting data along the transect in a coordinated manner, in a in a systematic manner. So in such case, these ship-based observations are really useful. So, and of course, if we are particularly interested in some particular region, uh, so like if we wanted to go there to some particular region, either it may be a Gulf of Mannar or it could be any other region. So, in such kind of targeted systematic studies, these ship-based observations are very much useful. So, and then uh, related to we have data from coastal stations as well. So this data is actually useful for precipitation related observations and weather stations, and particularly tide gauges for sea level variations. So these are the uh, various ways we are collecting data from different platforms for different measurements. So, and then coming to different data processing softwares and visualization tools we generally use in ocean related applications. So we have SEDA software that people actually use for ocean color data related processing and visualization, and Snap data for Sentinel data processing. And nowadays, we are actually focusing more using programming. So you can use Python or MATLAB or R programming or Ferret. So whichever programming language you are comfortable and suitable for your application. So you can even use programming tools to read the data and to compute, to perform some computations and to generate some plots and different maps visualizations. So obviously, you many deep plenty uh, default libraries are there in Python. You can literally make use of it. So, and when it comes to proprietary or open source softwares, for particularly coastal applications, as I just mentioned, shoreline change detections, mangrove mapping. So, for such studies, JS we can use, and for image processing, LDAS we can actually use, and of course Google Earth Engine. In last 3 to 4 days, you might heard about Google Earth Engine applications as well. So lot of ocean related data is available on Google Earth Engine as well, along with land remote sensing and atmospheric remote sensing. In the coming slides, I will show you some data sets which are available on Google Earth Engine. And as I just mentioned, coming to visualization tools, Ocean Data View software is available, and Panoply package is also available. So these are all the various data processing and visualization softwares people generally use in oceanographic applications. So uh, with this, I hope um, you got some understanding about uh, satellite oceanography, what are all the parameters we actually deal with satellite-based oceanographic applications, and what are all the different sensors in passive and active type, and uh, different spatial resolution, temporal resolution of different commonly used sensors or satellites in oceanography. So, and then different in situ platforms, and as well as uh, data processing and visualization softwares. Hope with these slides, you guys, all you people got some understanding. I won't say it is in-depth discussion. Some brief overview about some how we actually work in oceanography, satellite oceanography particularly. So up to this, if you have any questions, you can ask me.
मीटिंग के लिए सिर्फ हम रहेंगे। नहीं, यूजुअली क्या करते हैं हम इस टाइप के वर्कशॉप के लिए, हम और गिने चुने लोग
So Darga sir, am I audible?
उनको इन करवा देते हैं, बाकी के सारे जो है यूट्यूब पे ज्वाइन करते हैं। हाँ, वो बढ़ता रहता है ना काउंट।
Can somebody respond in chat?
जो भी इंटरेक्ट करने वाले हैं ना, जो हमें पता है उनको सिर्फ लिंक प्रोवाइड करेंगे।
Yes, sir, you are audible.
जैसे
Okay, ma'am. Thank you.
इंटरेक्टिव
So, okay, let's continue.
क्वेश्चन हम तैयार करते हैं और उनके बिहाफ पे हम पूछते हैं क्वेश्चन।
So, as I just mentioned, in major, if you see, let's say some
वहाँ जैसे
10
हम
publications or 10 research works related to satellite oceanography, in among those 10 publications, 8 out of 10, or even you can say 7 out of 10 or 8 out of 10 studies actually they actually deal with this chlorophyll and sea surface temperature data. That's why I would like to give you some insights related to chlorophyll and sea surface temperature data in this presentation, how to work with those parameters. So that understanding will definitely help you. Uh, that will actually give you some basic platform to work on further. So related to chlorophyll, as I just previously mentioned, this chlorophyll is related to ocean color related parameter, ocean color remote sensing related parameter. So this is actually based on whatever water leaving signal we are collecting at sensor. So that water leaving radiance is actually the we can say like uh, the output that is actually received at the sensor from the ocean. So this signal before it crosses, it travels towards sensor. So it actually interacts with the ocean components, different water constituents. So during that interaction, there will be a backscattering, absorption, and scattering, as you heard in atmospheric remote sensing. So here also, the incoming radiation from the sun, first it will interact with the water constituents, and then the water leaving signal we are actually capturing at the sensor. So during this interaction, backscattering, absorption, and scattering takes place. So uh, based on the data, we are actually collecting whatever radiance data. As I just mentioned, radiance data at different spectral bands. So that data we can actually perform some inverse modeling to estimate whatever interested parameters. Either it may be chlorophyll or suspended particulate matter or turbidity, whatever it may be. So this is one such algorithm, or we can say one biooptical model. So as I just mentioned, so this remote sensing reflectance RRS in this formula is nothing but remote sensing reflectance. This is one classical example. Okay, so uh, like if we have remote sensing reflectance data, or we can say in a simpler terms, radiance data at sensor or at different wavelengths. So we can apply the radiance we measured at green wavelength and blue wavelength. So with these two measurements in the green wavelength and the blue wavelength, if we substitute in this formula, we can actually compute chlorophyll A concentration. So this is actually a OC3M algorithm. So similarly, if somebody wanted to estimate total suspended matter, for that we can actually, in literature, we can find similar algorithm. So that algorithm, again, it also involves giving input as radiance data that is being collected at the sensor. So that data, if you give in that corresponding algorithm or formula, that will calculate whatever physical parameter we are interested. So whatever in ocean color remote sensing, all these water constraints more or less actually estimated from radiance data observed at satellite by means of any algorithm, by means of any standard algorithm at global scale or regional scale. So this is one example how chlorophyll can be estimated from the measured radiance at green wavelength and blue wavelength at any ocean color sensor. Let's say ocean color monitor or MODIS or CWIPS or VIIRS, whatever it may be. So like this, we can actually compute different parameters. So this is how we can expect chlorophyll global map. This is some example map showing how upon applying the algorithm or equation that I have shown in previous slide. This is how we can get chlorophyll A distribution in the global ocean. Okay. So this chlorophyll, as I just mentioned, it is actually one of the um, fundamental parameter in ocean climate related studies. So because this parameter is crucial for marine primary productivity, because chlorophyll actually uh, we can straight away relate chlorophyll A concentration to phytoplankton biomass. So this phytoplankton biomass is actually the fundamental thing in the marine food web. So obviously, in order to study marine productivity, food web, so obviously this chlorophyll A concentration is very much required. So and this chlorophyll A data, as it is a good proxy for phytoplankton biomass, and this phytoplankton involves in photosynthetic activity in the oceans. So obviously, this chlorophyll A variation can be related to study carbon cycle, to study carbon cycle. And even further we can say climate change related studies also, this chlorophyll A is very much fundamental parameter, since it is directly gives information about carbon sequestration through photosynthetic activity, and particularly we can actually say biological carbon pump. And this chlorophyll again having its high importance in studies related to fisheries management. So if somebody is interested in identifying potential fishing zones, so obviously fishes will tend to accumulate or aggregate phytoplankton and zooplankton. So if you have chlorophyll data, that data can be related to map potential fishing zones along with other relevant parameters like temperature and nutrients. So, and further, uh, we can use chlorophyll data to study harmful algal blooms. So, whenever there is a high, enormous amounts of influx of nutrients or pesticides from the inland to oceans. So, in those coastal regions, we often see uh, harmful algal bloom formation. So because of these enormous levels of algal bloom contamination, so in that region, whatever ecosystem is there, biodiversity is there, that will get badly affected because of the toxins that these harmful algal blooms going to release. So in terms of pollution or aesthetic point of view, so this harmful algal bloom monitoring is of high importance. And current scenario, because of this climate change scenarios, obviously the frequency of occurrence of these harmful algal blooms is actually increasing. So obviously this chlorophyll is one of the important parameter to study this harmful algal bloom monitoring. So and as I just mentioned, to study coastal water quality monitoring. So obviously chlorophyll and sea surface temperature, suspended particulate matter. So these parameters are very much together. We have to use it for to study coastal water quality monitoring. So when we talk about particularly marine pollution or coastal water quality parameters, usually in literature, if you see, these studies are actually based on multiple parameters, not just single parameter in general sense. So obviously chlorophyll and sea surface temperature, as I just mentioned, suspended particulate matter, nutrients concentration, so turbidity, all these parameters together people are using to compute water quality index on a scale of 0 to 10, or depends. It depends upon our interest. So we can actually generate water quality maps and to monitor in a long term. So coming to different satellite data sources available for chlorophyll A data. So primary one is Ocean Color website by NASA. So in this website, you can actually download ocean color data from different ocean color sensors like CZCS, MERIS, CWIPS, MODIS Aqua, VIRS, so OLCI. So, like that, many sensors data is available on this website. So for the beginners, level 3 and 4 version is more easy. Uh, you can get the data at different temporal composites also. Daily data you can get it, weekly or 8-day composites are available, monthly composites are available, and seasonal composites, and even running mean data is also available. Running means 7-day running mean, 30 days running mean. So like that, different temporal binning is available. Data sets are available here, bits, and even at different spatial resolutions also available. So this Ocean Color website is like a primary website, we can say. You can find almost more than 3 decades of data from this website. Okay. So, and here not only Modis Aqua, as I just mentioned, different other ocean color sensors data also available. And along with chlorophyll A concentration, you can find radiance data measured at different wavelengths also. You can find that data also. So if somebody is interested in some advanced studies, so obviously starting your work from radiance level is actually useful. So you can actually, as I just mentioned, radiance data is also available. And next slide, I will, in coming slides, I will discuss sea surface temperature data is also available. So like that, many ocean color related parameters, and we can say optical properties, inherent optical properties data is also available. Like that, many ocean color related parameters you can actually download from this open source website, Ocean Color portal, Ocean Color website. And if somebody is interested in advanced level studies, I suggest you to go with level 2 data or level 1 data from the same website. You can find level 1 and level 2 data in this website also. So such level 2 data will be of even more uh, high in spatial resolution, depends upon the satellite. So you can make note of this website, Ocean Color website by NASA. So and another website by European Space Agency. This is also Ocean Color Climate Change Initiative. So here also all the ocean color related data sets you can find along with chlorophyll A concentration data. So and particularly here in this website, this chlorophyll A concentration data is actually a merged product of different ocean color sensors like Modis Aqua, CWIPS, Maris, like that, VIRS. So they are actually merging different ocean color data source, ocean color sensors data, and they are computing, they are estimating chlorophyll A concentration and other ocean color parameters. So this website is also very much useful uh, for chlorophyll and other related climate variable study. And this is our India's website. So this website we call NICIS portal maintained by NRSC Hyderabad. So in this website also you can find all the like chlorophyll A related data products and other climate change related data products from this website, NICIS portal by NRSC. So all these data sources are openly available. And this one, what actually this data product is from Google Earth Engine. So in Google Earth Engine, with this link, you can find uh, entire Modis Aqua data on the Google Earth Engine. So this is the data product link. So you can explore this product. And then second essential climate variable that we are interested. So as I just mentioned, temperature previously. So uh, So temperature is also a fundamental parameter. Whatever long-term trends in ocean warming people are studying are air sea fluxes. So on how they are impacting cyclone formation, cloud formation, and further how rainfall. So all these things, this sea surface temperature is actually the fundamental parameter. So and even we can actually study climate prediction. So how El Nino and Indian Ocean dipole, such climate modes are how to study such climate modes and to forecast such climate modes. So obviously, sea surface temperature data is actually useful, and to study ocean circulation. So how ocean circulation is taking care of heat and energy distribution from poles to equatorial regions and equatorial regions to poles, and to study different ocean currents. So this temperature data is actually fundamental data. So in this picture, you can see the Gulf Stream propagation of Gulf Stream in the eastern part of United States. So, as I just mentioned, this temperature is highly useful for ocean warming, marine heat waves, and tropical cyclones, seasonal forecasting, and climate modes like El Nino and IOD, and to identify ocean currents, ocean water, ocean fronts, nothing but differentiation between different water masses, ocean heat transport, and mesoscale eddies like circular features, circular water movements in the ocean, and particularly phytoplankton growth, productivity, fisheries. So for all these applications, sea surface temperature is actually a fundamental parameter. So that's why I previously mentioned, if you see 10 studies related to ocean climate, in out of 10 studies, at least 8 studies, they actually use this temperature data and the chlorophyll data. So these are all the data sources that you can get the temperature data first one we can say like this is based on NOAA AVHRR sensor data. So this data is available at mm, one 0.25 degree spatial resolution. We can say 25 kilometers at the equatorial regions. So daily data is available in this website. Not only daily data, they are also giving temporal composites of monthly and annual data, seasonal data, and as well as they are giving anomalies data also in this website, temperature anomalies. So such anomalies data is very much useful if we study marine heat waves or tropical cyclones, such applications. So this is another website. Again, as I previously mentioned, from Ocean Color website, you can actually download sea surface temperature data as well from VIIRS sensor and MODIS aqua sensor. So this is one Google Earth Engine based product of similar one. Previously, I just shown Nova AVHRR product. So same data product is available in Google Earth Engine also. So this is same again MODIS aqua product also available. In that, along with chlorophyll, sea surface temperature data is also available. So and so far I actually discussed about two essential climate variables: temperature, chlorophyll, their applications, their importance in different oceanography climate related studies, and what are all the various satellite based sources that you can get the data at different resolutions in terms of time and space. So now I would like to show you some websites where you can actually get the in situ data related to oceanography applications. So first one we can say World Ocean Database. This is NASA's we can say NOAA website. So in this World Ocean Database from around 1960s onwards, lot of field data you can actually obtain from this World Ocean Database website. So all these data sources are open source only. So and another that particularly this World Ocean Database, so you can get plenty of data related to temperature, salinity, plenty of data, and apart from that, many other biological parameters also available. So, and this CBAS website. So, this CBAS website is actually mainly focused on uh, ocean color remote sensing, ocean color related in situ data products like uh, radiance data and as I just mentioned, chlorophyll data, optical properties, uh, suspended particulate matter. So likewise, many ocean color related products you can actually get it from this CBAS website. So and then another product, another website is actually related to SOCAT. So this website is mainly maintaining in situ data related to carbon cycle related parameters along with temperature, salinity, chlorophyll. So you can actually get it partial pressure of carbon dioxide. So like that, different carbon cycle related parameters you can actually get it from this website. So and another type of data is ocean reanalysis data. So this is another type of data. This is actually based on numerical models and satellite data and in situ data. So it's like a combined outcome obtained from all the three sources. So this data is also people widely using in various applications. I will give you one best example. So whatever satellite sensors we have, that data is available at surface level, direct measurements. But we cannot directly get subsurface data from sea surf in the deeper layers. And whatever field observations we have, let's say Argo floats, that data is available at different vertical depths. But It is not a continuous data. We cannot get that field data everywhere, every time. So this ocean reanalysis is like a complement combination of these two, we can say. It is taking advantages of both. So by taking help from numerical models, either MOM, HICOM, such numerical models or any bio-optical models, so these models are capable of giving data at surface to deeper layers throughout the global ocean, throughout the ocean. So this is highly useful data given the limitations associated with direct satellite-based measurements and direct in situ observations. So this Copernicus uh, marine services, you can find plenty of various ocean reanalysis data products from this website. So data is available for temperature, salinity, chlorophyll, sea surface height anomaly, waves, so nutrients, phytoplankton, functional types. So likewise, many oceanographic parameters you can get it from different ocean reanalysis products from this Copernicus website. And then this is another website. There you can, it is like a this web page is like a collection of different ocean reanalysis products. If you go through this web page, you can find different ocean reanalysis products and their corresponding website links. So coming to analysis methods, so let's say we have data for many years. So our target is to bring science from the data. So whatever data we are collecting from satellites or in situ sources, our end final interest is to bring some science. So for that, obviously, some rigorous analysis to be performed is to be performed. So there are different ways of analysis methods, depends upon our interest. So if you are interested in studying temporal variability, what are all the temporal modes of variation in particular parameter? So obviously, time series analysis is very much useful. Many people are already aware of this time series analysis. So one critical point here is one cannot use data directly in time series analysis. So there are some considerations why I'm saying if you are interested in long-term trends, if you are interested in studying long-term trends, then before you start your trend analysis, you have to remove seasonal cycle. You have to remove seasonal cycle and then that that de-seasoned data has to be used for long-term trends analysis. You should not use direct data. Okay, but if you are interested in seasonal cycle related studies, in that case, you can use whatever data is directly available. So this you please note down. So when you perform time series analysis to study variability of any parameter, how over a period of time, how that parameter is varying, is there any periodic oscillations? So, or is there any anomalous behavior at particular time, any extreme event? So, if you wanted to study such factors, you have to remove seasonal cycle from the data. Seasonal decomposition you have to do. And if you are, as I just mentioned, if your interest is itself seasonal cycles, seasonal variability, then you can use directly. So these are all the examples how time series analysis and long-term trends computation will be done usually. And another important point, whenever you are actually you are presenting any trend analysis like this map, you must show statistical significance of the trend also. simply just showing long-term trend value is not enough for paper publications. We must show in these trends what regions are experiencing statistically significant trends, what regions are not statistically significant trends. So such thing you should provide information. So we must show long-term trends, and we should provide information about whether those trends are statistically significant or not. And on top of it, when we compute trend value from a long time series data, obviously some uncertainty will be there. So that uncertainty you have to mention in the form of any metrics. For example, standard error. So we can, otherwise we can say 95% confidence intervals. So such information you should provide. So these things you should consider as a key elements when you deal with time series analysis. And this is anomaly identification. So if somebody is interested in identifying, analyzing marine heat waves, so for such studies, obviously, and even we can say extreme events related studies also. So anomaly computation, like computing long-term mean, we can say climatological mean, and subtracting climatological mean from the instantaneous measurement. So that will actually give you anomaly corresponding to that instantaneous measurement. So such analysis is useful to study marine heat waves or any anomaly related studies. So, and then spatial pattern analysis, we can say spatial variability analysis. So usually people uses empirical orthogonal function analysis or clustering analysis. So these analyses are required. So when you have long-term data of some 10 years or 20 years, if you wanted to study what is the spatial variability, spatial patterns in terms of its variability. So what regions are varying in a correlation. So in that way, if you wanted to study such spatial variability, this kind of spatial pattern analysis is very much useful. So one thing we can say, for example, Indian Ocean dipole movement. If somebody is interested to study such phenomena, obviously this kind of spatial variability analysis is useful. So the covariance of different locations in our study area can be easily identified. So in this spatial pattern analysis. So as I just mentioned, empirical orthogonal function analysis, principal component analysis, or we can even say clustering analysis by using any machine learning approach. So such analysis tools are there to perform spatial variability analysis. And correlation analysis. Obviously, people are interested in dealing or studying multiple parameters at a time. How SST is impacting chlorophyll A. So, or how SST is impacting rainfall precipitation. So, in such studies, obviously, we have to deal with multiple parameters at a time. So, in such cases, correlation analysis is very much useful to study is there any relation, mutual relation between targeted parameters or not? If so, whether it is positive way or negative way. So such things we can easily understand by performing this kind of correlation analysis. And then another important one is homolar analysis. So this is very powerful tool, powerful analysis of method. If somebody wanted to study both spatial and temporal variability in a single analysis. So if you see in this figure is actually related to Arctic region. So you can see the warming scenario or temporal and spatial scenario of ocean warming in the Arctic region. So if you can see from 1996 to 2009, so slowly you can see the increasing in warming condition. So that is very clear. and at what area with respect to time. From this figure, you can easily say from 1996 to 2019, there is an increasing trend in the Arctic warming. So that is about temporal information. So if somebody wanted to see spatial information, that information also we can see here. So whatever this uh, variation is happening, this variation is more in magnitude in this around 70 to 80 latitudinal range, and when it comes to longitude, around 10 degrees east to 180 degrees east and up to even 170 degrees west. So you can actually get some information about where this warming is happening, at what time it is happening. So such time space related information, if you wanted to study in your future applications, these homolar plots are very much useful. So, and another one, teleconnection related analysis. We can say this like a butterfly effect. So, in every phenomena, every parameter or every variability we are seeing in one location, there will be some teleconnection or some relation with uh, other things, whatever happening in the other location. So, simple example, uh, the temperatures we are experiencing in Indian Ocean, they have high relationship, high teleconnection with Pacific Ocean. So through by means of El Nino La Nino cycles. So likewise, and we can say Walker circulation. So this is actually, it's like a, for such kind of climate teleconnection analysis, one must have multi-domain knowledge. Oceanography knowledge is required, and atmospheric knowledge is required, and as well as land remote sensing knowledge is also required. So one must have some multi-domain knowledge to study one one area is affecting another area in a remote manner. So these are all the various analysis methods we can use based on our requirement. And coming to conclusions, as I just mentioned in satellite oceanography, we have advantage of collecting simultaneous measurements of different weather climate related parameters that will give you some complete or comprehensive understanding of ocean climate interactions in a short scale or in a longer scales. And obviously, we have multi-level data from multiple platforms, as I just mentioned. So that will definitely help us in terms of research and operational applications. So since we are going to have long-term data and continuous data throughout the global ocean, so climate trends and studying weather-related variabilities, extreme events, anomalous events, so and periodic events, so such things we can actually study you in satellite oceanography applications. And as I just mentioned, so since our satellite data is very much relevant to study coastal water quality monitoring, how ocean health is changing over a period of time because of anthropogenic inputs. So such information is useful to assess climate change as well as to make policies. And finally, with the ongoing research, whatever resolution or accuracy levels are actually gradually increasing. For example, recently NASA has launched one satellite called PACE. So with that satellite, we can actually now we were able to get highly high resolution data in terms of spectral variability. So like that, in terms of spatial resolution and accuracy, so research is actually going on, new satellite missions are coming, so we can overcome whatever certain existing challenges so far. So this is all about satellite applications in oceanography. what are all the different parameters, what are all the different applications, what are all the different data sources, and different analysis methods and their uh, importance. So thank you. If you have any questions, you can ask me. Yes,
Yeah,
please.
thank you, Dr. Vijay Kumar. If any
Vijay
questions,
Prakash.
please ask.
Hello, sir.
Yes, yes.
Thank you for your wonderful explanation on this. So my question is like, for example, we are conducting suitability for example, aquaculture suitability on like inland waters. So like we can take the different parameters and then we can process the overlay weightage and then we can get the suitability. So for like selecting parameters, we can, for example, for surface temperature, we can get like yearly data. So which year we can take, like if this is 2026 and we are going to uh, conduct the to process out the suitability, so like which year we can take, like it's 2020 data or 2025 data, or it's our type of average from 2020 to 2025 data. It's That's what I'm asking.
Okay. So, as I understood from your question, so you were expecting how to choose time period,
Yes, sir. Yes,
uh,
sir. Yes.
how to decide time period for site suitability analysis for aquaculture applications. So, yeah, in that actually, uh, there is no any fixed rule for choosing uh, this time period. So one thing you have to make sure when you perform this site suitability analysis, make sure that data will have proper representation of all the temporal variability in that study area. So whatever the time period you are going to consider, whether it may be any number of months or any number of years, so your data should represent temporal variability of that study region, whatever parameters you are targeting. So temporal variability, again here you should consider your data should represent seasonal variability. It means your data should have representation of all the seasons, and your data should have interannual variability. Okay, so that interannual variability, so there again it means you should have enough number of years data. So, like for aquaculture, if we talk about, so that is like a obviously some smaller study area. So, still, you can actually consider what are all the interannual modes of variability in either in temperature or chlorophyll or nutrients, whatever. So, you have to consider interannual variability means you must have enough number of years of data. That time period, that time span should have all this variability. For example, El Nino events or IOD events or monsoons. Monsoon, again, of course, we can say seasonal things. So, likewise, what are all the interannual variability modes are applicable to your study area? So all different climate oscillations. So all these climate modes and climate oscillations should be covered in your time span. Okay.
Yes, sir. So basically, like we have to cover a greater range of time. Like instead of taking like one particular year or two particular year, we can like take a decadal range to get the best result.
Yeah, and one critical point here is, let's say, uh, I will give you one good example. Let's say somebody has taken 10 years of data. So let's, for example, not only for your application, for any other applications, in that 10 years of applications, if there are no climate related modes or climate variability modes, there was no any occurrence of such modes. Let's say in that 10 years, there was no IOD event. There was no ENSO event. If you take that 10-year data and you perform, that is not a proper representation. So let's say if somebody has taken only 5-year data, in that 5-year data, 1 year has IOD representation, IOD occurrence, 1 year has ENSO occurrence, 1 year has together, and another year has normal year. So if, even though if it is 5-year data, when it is having representation of all these variabilities, that is actually good data. So it doesn't mean whether it is 5-year, 10-year, or 20-year, or 30-year. Whatever it may be the time span, it should represent all this kind of possible variabilities in terms of seasonal, interannual, and even decadal oscillations, if applicable. Is it clear?
Okay, sir. Thank you, sir. Got it, sir. Thank you.
Any other questions? Sir, if any questions are posted on YouTube, so maybe if somebody can read those questions, that is actually good. I will be happy to address those questions as well. Here I don't have access to see that YouTube live streaming.
Yeah, hello.
Yes, sir.
Yeah, Dr. I think no more questions right now, is right?
Okay, sure.
Yeah, wonderful. Thank you for sessions. Wonderful information you have given for the satellite applications in ocean data and oceanography, basically oceanography studies. So thank you for to give as a resource persons come to our course. So any more questions now, or we can wind up today? Okay. So if there is no questions, then I will tell you something to the those who are actually the more number of participants are joined in this program. So almost all 5,000 people are registered in this program. So what happened? Now we will give to the assignment to all the participants, those who are registered this course. So the assessment will be shared in the CSE website channel and this group. One group is there, WhatsApp group. So those who are submitted in the assessment report by Sunday, those fellows or those participants only they get the completion certificate of the this course. So we will share the this assessment form in the one is from the our WhatsApp channel and in the groups also. So all the groups, those who are registered in all the people, we will get the assessment assessment form. So please submit it by the Sunday itself, before Sunday. and after Sunday the evaluation will be start, and we will issue the certificate on Sunday evening or Monday. So thank you for giving the support from the financial support from the IITM Pune and Ministry of Environment and Climate Change, MoEFCC. So this is funded projects. That's why we have more the people are registered, more the participants are registered and benefited from the regarding this course. How to satellite applications in the different fields, from the starting to climate and weather, and second one from the air pollution, how to use the satellite applications in air pollution, and the third one will be the third one in the weather prediction and NCMWR numerical weather prediction. The fourth one in the fires and assessment, and the today will be the ocean technologies, oceanography studies. This is very highly useful course, and the most of the I hope most of the participants are understand the basic things. So thank you for joining this course and register this course. So by end of this week, the Sunday, we will get all the certificate, participation certificates. So thank you to all. Is there any questions from the audience? Hello? Okay, if no more questions, then we will wind up today. Okay? Okay, thank you to all. Thank you for coming.
Hello, excuse me, sir. Sorry, my net is not working well. My question is,
Yeah,
how we
okay.
prepared the assignment? How we prepared the assignment? Can you guide me? Because I am.
Sorry?
I am
No,
doing
everything.
my bachelor's.
Yeah. Everything is there in the Google form itself only. So very simple. Once we will, you receive the Google form. If any doubts or clarification, we will please post in the in WhatsApp group. So we will assign all the participants in the one WhatsApp group. You can post it there.
Okay, thank you so much, sir. Thank you so much for the making a wonderful course. That's why we learn something about our environment. Thank you so much. Thank you so much for making
Yeah.
a course.
Thank you for coming. So any more? Yeah, sure. Okay, fine.